right, so this is going to be the last video for confidence intervals, and this is about population proportions. If you are in an election year, you might see different confidence intervals for winning, and they have that like plus or minus type situation where that would be your margin of error. Also, you might want to know like which stocks are going up or down. There's a lot of applications as far as like doing projections and trying to figure out different proportions. And so we are going to have the same type of error bound or margin of error situation as we had with means and confidence level. The nice thing is we're going to be able to use the Z distribution. So we're not going to have to worry about the T distribution. There's also some really big connections here to a binomial distribution because we are talking about either proportion of happening or not happening. So you always, to form a proportion, take X and then divide by N. So the number of successes divided by the total, and that's how you're going to find your proportion. So one thing that we knew from before is as long as N is big and P is not 0, we like to say that like NP, some books say greater than or equal to 5, but a lot of books say greater than or equal to 10, and NQ greater than or equal to 10. What that means is the number of successes and number of failures, okay, are both greater than or equal to 10. And so as long as you have that, then we can use a normal distribution here for the binomial model. And so X follows these, like mean is N times P. Standard deviation is square root of N, P, and Q. But we don't want X, we want a proportion. So if that's the case, then you would divide these two things by N. And when that happens, then you end up getting that your distribution, let's call it, this calls it P prime, but our book calls it P hat. So P hat is going to follow a normal distribution where the mean of that distribution is the proportion that you're looking at, or in this case is going to be P hat, because that's what we have to use in order to approximate, okay, what's going on. And the standard deviation, with some algebra here getting used, right here, we end up getting the standard deviation. We're going to use P hat, Q hat over N. And I don't think you really need to know more about like why these are the way that they are. That's just how it's going to be. Okay, and so then your error bound calculation, or your margin of error, is always that critical value times your standard error. Well, our Z is going to be our critical value, and your standard error for your point estimate is going to be that standard deviation. And make sure you take the square root of that whole thing. All right, let's go ahead and look at a problem here. So suppose a market research firm wants to know the percent of adults living in a large city who has people who have a cell phone. 500 randomly selected adults in the city were surveyed. Of those surveyed, 421 said yes. So our P hat would be 421 out of 500. And so let's go ahead and say, well, then let's do the no's, like the Q hat. 79 would be our Q hat. And just for fun, let's go ahead and figure out what that proportion would be. So this is 0.842, and this is 0.158. All right, and then number of successes and failures, both greater than or equal to 10. So I can use a normal distribution and I can use z-scores here is what that means. Use a 95% confidence interval to estimate this. Now 95% with your normal distribution, we can kind of estimate using the empirical rule, right? So if you have this here, I know 95% or pretty close to 95% is going to be 2 standard deviations away from that, and then we'll use StatCrunch and get a little bit better of an approximation here. But let's go ahead and find our standard error. Oh, sorry about that. So that's going to be 0.842 times 0.158 all over n. And I end up getting 0.016. So let's go ahead and figure out what this piece is here. So that's going to be 0.875. I just multiplied this by 2 to get us to this here. And this is going to be 0.810. And so like a rough estimate is going to be about 81% to about 87.5% of adults in this city have cell phones. And of course, that's with 95% confidence, right? All right, let's go ahead and see if we can have StatCrunch give us a little bit more of a better estimate here. So when I go under stat and I go to proportion stats, I want to do a 1 sample and then with a summary because I just have like the input information. So I'm going to input number of successes, number of observations. I want to do a confidence interval, 95. This is just our standard method here. Yes, show the critical value. Let's not worry about doing a plot. And you can see our critical value is about 2. It's 1.96. Our standard error calculation that we found is perfect right here. Our proportion is perfect. And our lower bound and our upper bound are pretty stinking close with just using that plus or minus 2 standard deviations from the mean. But let's just say this was like a 90% interval instead. So I couldn't just use that like rough estimate of 2 standard deviations. Okay, notice that critical score is what's lower. That's the only thing lower though. Everything else stayed the same. I just changed the confidence level. And my confidence interval got a little bit smaller. Well, that's because now I'm only 90% confident that the proportion is between these two numbers. So the interval is going to be a little bit smaller or a little bit closer to this, like the width itself is smaller because my confidence level is smaller, my critical Z is smaller because I'm closer to the middle or what I find is my point estimate for the proportion here.